My friends, we are talking about Swiss Mathematical Olympiad 2024 second round task N2. Why N? Because it is about number theory. So the task: determine all positive integers n with the property that for each divisor x of n there exists a divisor y of n such that x plus y divides n. The divisors may be negative, and good luck. I like this point. Good luck, because they wish us luck with this task. Actually, it is the end of the paper with the problems. Then good luck. That's encouraging. Hope this will help. Oof. Okay, so it would be easy for me just to tell you guys the hypothesis and the solution, but actually the problem on Olympiad is not to prove the hypothesis, but to imagine it, to understand which hypothesis to offer. And so in order to understand what the hypothesis could be, we should start to touch this task really with our hands. So let us just see what is it. So let's consider simply n equals 1. N equals 1, this is not really good because we have only x equals 1, the only divisor, and for that we can figure out the other divisor which is the same, y equals 1. So, and 1 plus 1 is 2, and 2 does not divide 1, so it doesn't work. Then let us consider n equals 2, and for that we shall write all the divisors of 2. Positive are obviously 2 and 1, and then negative, negative 1, negative 1 and negative 2. Okay, so let us figure out what y should be. Y should be, so 2, it's already a lot. So 2, n equals 2 divides, n equals 2 is divisible by 2. It's already a lot. So we cannot, so if we want x plus y to be the divisor, we cannot add anything for these two. We can only subtract. But if we subtract negative 2, so we add actually negative 2, 2 minus 2 equals 0, we cannot divide by 0. And so the only thing that could work, not necessarily will work, but could work, is this negative 1. So for negative 1, and so does it work? X plus y, 2 minus 1 is actually 1. So it works. And now let us just try to pick the numbers y for all the remaining divisors x. So for this one we take negative 2, for this negative 1 we take positive 1, for this, for this negative 1 we take positive 2. For this negative 2, let us take a positive 1. Okay, so this is how it works. Then let's just, for those of you who probably does not yet understand what goes on, let us add them together, x and y. So 1 minus 2 is negative 1, 1 minus 1 plus 2 is 1, minus 2 plus 1 is negative 1. And clearly all these numbers, 1 and negative 1, they divide 2. So that is why for each x, for each possible x, we found y so that x plus y are the divisors. So it works for each value. So yes, this one is a good one. So good luck, we use the same color. We highlighted good luck and we highlighted n equals 2. Then let us continue to have a sense of what it is. Let us try n equals 3. And so we write our possible divisors x. These are 3, 1, negative 1, negative, why negative 2? No, negative 3, of course. Okay? And so for this, we write the values of y. Let's try to write them. The only thing that could work, nothing positive again can work, and nor negative 3 can work. Only negative 1 can in principle work, but will it work? So in order to reduce x plus y, so which gives us x plus y of 2, but 2 does not divide 3, and this is a really bad one, bad divisor. Aha. And here, look, here we start to figure out that actually the largest divisor should equal the number, and the second largest divisor by which we can delete should be half of x. Here it worked 2, and the next one was half of 2. Here it doesn't work. So if we reduce it, if we reduce 3, we should reduce it by at least a half. So like try something 3 over 2. It doesn't really work here, but this could work if we have it here, 3 over 2. And in order to have 3 over 2 here, we should have something pretty substantial at absolute value here, not -1. Look, -1 is not enough. I wish we had -2, so 3 plus -2 would be equal to 1, but we don't have it. So and n equals 3 is a bad number. It doesn't work, so we crossed it out. Just let us explore this idea with the second best option a little bit further. So let's take n equals 21. We consider all the divisors in descending order: 21, 7, 3, 1, and then -1, -3, -7, -21. And then we try to get y. Again, as I told you before, the first y should be negative, but the second smallest negative number is -7. And even if we take -7, x plus y is equal 14. And 14, 21 over 14 is 3 over 2, which is not enough. So again, some number, I don't know, 36. The second divisor, the first divisor 36, second divisor should be at least half the first divisor, should be 18. Nothing in between. And it works for all these even numbers. Okay, so what does it come, which idea does it give us? That it doesn't really work for odd numbers, because odd numbers we cannot halve x plus y relative to x by subtracting some negative divisor. They're simply not enough. And of course, -3 and -1 would make matters only worse. We would We would have here 18 or 20. And it worked with n equals 2. And it appears that with positive number, I know 36, we have, what do we have it for here? We would take -18, and x plus y would be +18. So it appears we can make a hypothesis. Again, this one is no, and this one is probably yes. So the hypothesis, I can't really say. Can you say it properly? Hypothesis. Like hippopotamus, the animal, the behemoth. Hypothesis is that n should be even. And in order to work with this hypothesis, we have to work with the following statement. First of all, we need to prove that for when n is odd, it doesn't work. And second, what we need to prove that when n is even, so wait, odd doesn't work. And when n is even, it always it always works. Okay, so let's prove it. If we consider some odd number, uh, then it can be broken down as the uh, prime numbers with their powers according to the basic theorem of arithmetics. So a1 in the power of alpha 1, a2 in the power of alpha 2, a3 in the power of alpha 3, and so on. And without loss of generality, let us consider that a3 is greater than a2 and is greater than a1. And a1, since the number is odd, we don't start with 2 here. a1 is greater than 2, so basically it is at least 3. So a1 is greater or equal than 3. So, and then when we try to write x, all the divisors, we start with n. It's the largest divisor. And the second largest divisor is like it was here with 21. The second largest divisor is this n divided by 3. And so, because look, 21 was 3 times 7. So we divide the largest divisor by the next smallest divisor. So here it works just the same way. The second largest divisor of n is n is if we take instead of alpha 1, we take it alpha 1 minus 1. So the second divisor is n over a1. And so there goes some other divisors, and then we have like somewhere here 1, -1, and all repeats in ascending order, but with a negative sign. Minus n over a1, and then we have minus n. Right. Now we have, let's try to get y, such that for x plus y that would work. So again, we want to, we need n negative and as great in absolute value as possible. So we want, for x plus y, we want to have this number very small. So let's take, we cannot take a negative n because n minus n would be 0. So we take the second one. We take minus n over a1. And so for x plus y, we get n minus n over a1. And this is the smallest number we can possibly get for x plus y. But let us evaluate. Since a1 is greater or equal than 3, then this statement is greater or equal than n minus n over 3, which gives us 2n over 3. And n obviously is not divisible by 2n over 3. So we have proven that for odd numbers it doesn't work. It never works for any odd numbers. The second thing we need to prove is that it always works for even numbers. And in order to do it, we must show how it actually works. So let's first of all take some odd number m, and let us consider just like we took n here, and let us consider its divisors. The greatest one we call m itself, then goes some m1, some m2, and so on, like 1, -1, and so on. Then goes negative m2, negative m1, and then we have negative m. Here they go. Here they go in ascending order, in descending order, and here like in absolute value in ascending order, but since they're negative, it's also a descending order. Right, so these were xm, And then if we take n, since n is our even number, let's get it by multiplying this odd number by 2m. So the divisors of n equals 2m are going to be the following. The greatest one is obviously 2m. And look, since it works just the same way as here, the greatest divisor of m and the second greatest divisors are different at least 3 times, not 2 times. So when multiplying by 2, they get exactly in this order: 2m, then m, then 2m1. 2m1 is not going to be greater than m. 2m1, then m1, and so on. It doesn't really matter even if it will arrange this way, but and so on. 1 minus 1, then negative m2, negative 2m2, negative m, negative 2m. So then let's try to build yn such that it would work for xn plus yn, and we will use this scheme from here. So for 2m, the second largest divisor of 2m is m after 2m itself. So we want here m, and can we get it? Of course we can. We can get yn equals negative m. So 2m minus m equals m. And for this one, just like we got here negative 2, let us get 2 minus 2m. And adding them together gives us minus m. For these divisors 2m1, we subtract negative it's m1 and m1. We subtract negative m1, so we subtract negative m1 and we get m1, and so on. For this one, obviously we use minus 2m1, so we get m1 here, and so on. And for the negative, we do it just with the reverse sign. For example, for the last one, here we subtracted negative m, here we add positive m, because it works for both positive and negative numbers. It's a symmetry here, so it doesn't really matter. Minus 2m plus m equals minus m. Thus, we have shown that for even numbers, that's the second part, it always works. It always works. So thus we have proven that for wrong odd numbers it never works, the hypothesis that n should be even, and for even numbers it always works. We showed how it works, and we showed the intuition. How did we approach this idea of the hypothesis that we should get? So then our hypothesis is actually a solution that n should be even. Right, okay, so was it clear? Write me in the comments, and don't forget to put a like and subscribe to my channel. Okay, thank you.